In this lesson, you will learn how to solve special right triangles. There are two types of special right triangles, a 45-45-90 and a 30-60-90. For a 45-45-90, the legs of the triangle will be equivalent or equal to one another. The hypotenuse is going to be x, or the leg, times the square root of 2. In a 30-60-90, the shortest side, which is the side of the triangle that is opposite the smallest angle, which is the 30-degree angle. So the smallest side is going to be represented by x. The hypotenuse is going to be 2 times that smallest side. And then the other leg is going to be the square root of 3 times the smallest leg. Let's look at the steps to solve these special right triangles. The first most important step is to identify the type of special right triangle. You're either going to have a 45-45-90 or a 30-60-90. Look at the given information to help you identify the type of special right triangle you are working with. Step 2 is to identify and label the legs and the hypotenuse. The hypotenuse is always the side that's opposite the right angle, and the legs are the sides that meet to make that right angle. It's very important when working with the 30-60-90 to carefully identify and label the legs, because notice they are not going to be the same as they are in the 45-45-90. Both legs are equivalent, to where in a 30-60-90 it is important that the leg across from the 30-degree angle is your smallest side, and the leg opposite the 60-degree angle is going to be x, the square root of 3. And the third and final step is to set up the equations to solve for the missing sides. So let's look at our first example. Here we need to identify the type of special right triangle. So looking at our triangle, we see that it's a 45-45-90. We will now identify and label the legs and the hypotenuse. So starting with our legs, they will each be represented by x, and our hypotenuse is going to be represented by x, the square root of 2. A way to help you remember this is because both legs are equivalent and you have 2 legs, we have x times the square root of 2 as our hypotenuse. So now let's solve for the missing sides, where the given side is PR, that's 2 to the square root of 6. The other leg, QR, or you can also call it RQ, so our side RQ will also be 2 to the square root of 6, because it is the other leg of this triangle and they are going to be equivalent for 45-45-90s. So the side PQ is x, the square root of 2. And notice we were given x as our leg, which is 2 to the square root of 6. So we can plug in 2 to the square root of 6 into the x to solve for the hypotenuse. So we'll have 2 to the square root of 6 times the square root of 2 to equal our side PQ for our hypotenuse. So now we can take and multiply together what's under the radical. So 6 times 2 is 12. We will need to make sure that our answers are in simplest form, so you should have previously learned how to simplify those radicals. Do your prime factorization of 12, dividing by prime numbers. Be very careful. You should find the prime factorization 2, 2, and a 3. Notice we have a pair of 2's. So we already have a 2 out front. That was just part of the work already there. So a 2 is already out front. But then with the pair of 2's, we're going to bring that one out as a 2. And then under the radical, we keep the 3. So 2 times 2 is a 4. The square root of 3 is the answer for our hypotenuse. So the length of PQ is 4 the square root of 3. Let's look at example 2. Again, notice this is a 45, 45, 90 triangle. So identify and label your sides of your triangle. Your legs will both be equivalent and equal to just x. The hypotenuse is going to be x the square root of 2. You can remember there's 2 equivalent sides, so I'm using a 2 here for our hypotenuse to help you set it up. Well, this time we're not given x. We're actually going to have to solve for that. We are given our hypotenuse, which is side AB, that equals 10. We'll have to use that to solve for x in order to know what the lengths of our legs are. So if 10 equals x the square root of 2, we can use that to solve to know the lengths of our legs. So to solve, we'll need to divide by the square root of 2. So notice that does get x by itself, but it leaves us with 10 over the square root of 2. You should have learned that we are not allowed to keep a radical in the denominator, meaning we are going to need to rationalize the denominator. So we will multiply by the square root of 2 over the square root of 2. Rationalizing the denominator will get that radical sign out of the denominator. So we have 10, the square root of 2 in the top. Square root of 2 times square root of 2 is the square root of 4. But that is a perfect square, which is what we want. And so that makes it simplify. The square root of 4 is 2. And we will take one final step to reduce when we can with these fractions. So 10 divided by 2, that can reduce and just equals 5. So our final answer for our legs, remember we were solving for x, so x equals here 5 the square root of 2. And because both legs are equivalent, this will be the side length for both AC and CB. Let's take a look at example number 3. Notice the note. Don't overcomplicate it. Sometimes we can just look at the picture and quickly be able to solve and identify. Notice again it is a 45, 45, 90. So of course our legs are going to be represented by x, and our hypotenuse is x the square root of 2. So notice if our leg is x, this side is already given to us xy, so that is an 8. And also yz is an 8. So both of those are equivalent and both represented by 8. But notice the hypotenuse. It says it's x square root of 2. Well, we know x, so just plug that in, 8. And don't forget your square root of 2. Yes, it can be that easy sometimes with these special right triangles. There's not much to set up and solve because it gave you x. You need another one here for this leg, and then plug in x that was given to you. So x, the square root of 2, will give you your hypotenuse. So it's just that simple as plugging things in sometimes. Let's look at now some 30, 60, 90 triangles. So number 4, it is important to identify the type of triangle you're working with so you know how to label your sides. So this one is a 30, 60, 90. So always start with the side that is opposite your 30-degree angle when you're labeling. So I start with that as an X, and then move around the triangle to the hypotenuse next. So this is X, then go to your hypotenuse, which is across from your 90-degree angle. That's going to be 2X. And then the side across from your 60-degree angle is going to be X, the square root of 3. So with 30, 60, 90 triangles, think about it as a 1, 2, 3 when you're labeling. Across from the 30-degree angle is X. Then go to your hypotenuse is 2X. And then across from your 60-degree angle is x the square root of 3. So 1, 2, 3 when labeling your sides. That's why I say carefully identify and label, because you do have each one of them being different on each side. So let's set up our equations to solve. Well, first find your given side. EF is given. That's 5 the square root of 3. And then use that given side to see what you can set up and solve. Well, 5 the square root of 3, they say, is x. So x is 5 the square root of 3. You could start with either side to solve. I'm going to start here with DE because it tells me, hey, once you know x, just multiply it by 2. So that's what I'm going to do. I'm going to take DE and solve for it, which is 2x. If I know x, I can plug that in. 2 times 5 the square root of 3. So notice I just need to multiply in order to solve for that missing side. So 2 times 5 is 10. And of course we just bring down our square root of 3. Be careful, you would not need to multiply 2 times the square root of 3. Because first of all, that's under a radical, so he's protected by that square root symbol. That's not really a 3, so you can't just say 2 times 3, which is 6, because that's not really a 3. That's a square root of 3. Also, 2 times 5, you've already multiplied that together. You cannot keep distributing, because this does not work like the distributive property. When it's just multiplication, you can just say 2 times 5, which gives us 10, and then of course bring down your square root of 3. So the length of DE, which is our hypotenuse, is 10 the square root of 3. So now we're going to find the side of DF. DF is represented by x the square root of 3. We were given x from the beginning. That's the length of the shortest side. So let's plug that in. So 5 the square root of 3 was our x. Then we have square root of 3 as part of our side of our triangle. Now we just multiply. Square root of 3 and square root of 3, they can be multiplied together. 3 times 3 is 9. Hopefully you recognize 9 as a perfect square. So the square root of 9 is 3. Notice once I take the square root of 9, I no longer have that symbol, that radical symbol. The square root of 9 does not equal the square root of 3. The square root of 9 just equals the numerical number 3. So now we need to multiply 5 times 3, and that gives us 15. So the length of DF is 15. Let's take a look at another 30, 60, 90. Number 5. Here again, it is a 30, 60, 90. Start with the shortest side, so the side opposite your 30-degree angle. That is your x. Move around the triangle, finding the hypotenuse next. So here's the shortest side. Our hypotenuse is actually the longest side. It's across from the 90-degree angle. That's going to be 2x. And then the side across from the 60-degree angle is going to be x, the square root of 3. So again, remember 1, 2, 3 to help you set it up. Well, this time we're given LJ. So LJ is 9. Start there to help you set up. So if 9 is going to equal x, the square root of 3, that was our given side. It represents x, the square root of 3. We can solve this equation for x to be able to find the missing sides. So let's solve. We're going to need to divide by the square root of 3. So that's going to leave us with x equaling 9 over the square root of 3. We cannot leave this in this format because we're not allowed to have radical signs in the denominator. So you'll need to rationalize the denominator by multiplying by the square root of 3 over the square root of 3. So in the numerator, we have 9, the square root of 3, and then in the denominator, 3 times 3 is 9, so you have the square root of 9. You should notice that as a perfect square. So we have 9, the square root of 3 over the square root of 9 equals 3. Whew, there's a lot of 9s and 3s here going on, so be careful and neat with your work. So we've simplified the denominator and gotten that radical out of the denominator by rationalizing it. Now we just need to check to see can we reduce, and we can. 9 and 3 can reduce. 3 goes into 9 3 times, so we have 3, the square root of 3. So all of that work was for x. So when we solved for x, that gave us the side for jk. So jk is 3, the square root of 3. So our last step is to find the length of the hypotenuse 2k, or 2x, not 2k, but 2x. Well, we just found x, so 2 times that, which is 3, the square root of 3. This is for 2x. We can multiply 2 times 3, which gives us 6, the square root of 3. And so that gives us the length of, what was that, LK. So the length of LK is 6, the square root of 3. Let's look at one more 30, 60, 90 triangle. Feel free to pause the video and try this one on your own and come back and check your work. Starting with the side opposite the 30-degree angle, let's label it x. Then go to the hypotenuse, it's 2x. And then we have x, the square root of 3. We can set this up by 1, 2, 3 for 30, 60, 90 to label and identify our sides. So start with the given side. We have LK. So LK is 4, the square root of 3. So we'll use that 4, the square root of 3 to set equal to our given 2x. And use that to solve for x. So divide both sides by 2. 2 goes into 4 2 times. So that gives us the side for the jk side, which is represented by x. By solving that equation, we get the length of the shortest side. So x equals 2, the square root of 3, which is jk. So finally, we need to find LJ. So we'll work here. Let's see. LJ is x, the square root of 3. Well, we just solved for x, so let's plug that in. 2, the square root of 3. That was our x, and plug that in here. So we're going to take 2, the square root of 3, and multiply it by the square root of 3. So 3 times 3 is 9. Again, hopefully you recognize that as a perfect square. 9 is a perfect square. So 2 times 3, which gives us 6. So the length of LJ is 6.